All right, happy Friday, guys. Happy Friday. Hope you're excited for spring break coming up here soon. Don't forget to watch this video before you take your mini quiz. You need to be taking these mini quizzes for attendance. As for your homework, I'll be collecting every single assignment that you've done this week on the first day that we get back, whether that's the Monday or the Tuesday. We'll find out eventually, but that first day we'll get back, I'll be collecting every single assignment. It's just going to go in as one big homework grade. So keep on top of that one. A little Miami Vice, Miami Heat color scheme inspired by this little Tiffany blue color that I found existed here in my Apple Pen. I don't know, what do you want to call that? Like a color palette, I guess? Anyway, let's get back to reviewing for Chapter 10. So we're going to name 2 radii. Again, you can always pause our videos here, fill these out, and check in a minute. So radii, again, from center of the circle, center of the circle to the edge. It's a segment. So you got AC, don't forget the little segment symbol, and AB. Of course, if you did CA and BA, that's fine as well. Name a secant. Secant, you need something that goes through the circle twice. It's got to be a line. It goes all the way through. So CB or BC, as long as you got the line above it. Can't be a segment, must be a line. Now we're going to name a tangent and its point of tangency. Tangent only touches the circle one time. And that point of tangency, where is it touching the circle? So DE or ED, depending on how you want to name that. As long as it's got the arrow up top, the big line symbol above it, line DE, tangent at point D. So D is that point of tangency. Now we're going to name a chord. Again, we're looking for something that touches the edge of the circle twice, endpoints on the edge of the circle, but is a segment. So again, this is where it gets very important to use those correct symbols. So if I'm going to name a chord, CB, as opposed to a secant, here's a secant. It's got that line above it, whereas a chord is just a segment. So that's why we're very careful about that. Now, a central angle, I guess use a lot of central angles. CAB would be one. BAD would be one, the bad angle. And then an inscribed angle, and this is an angle where it's got a vertex on the circle. So here's an inscribed angle. If you want to call it like ACB, why is it doing that? ACB, that would work. So you got to keep your vocab fresh in your mind here. And let's think about, what do we know about these central angles? Again, angles with their vertex in the center. How do they relate to the arcs they intercept? Well, they're the same. So if the arc here is what we want to find, look for that central angle that intercepts it, 123 degrees. Now here we want to find our missing central angles. Oh, I'm sorry. I meant to put my question mark here. I was a little confused as to why I did that. So there's my central angle. Just, see if I can almost sort of artificially erase this. There we go. Yep. That's the central angle I was looking for. Sorry about that typo. So if the arc is 155, then what's the central angle? Well, that must also be 155. Now look at C. I want you to think about, what do you see here? What do you notice about that segment? And then what other things do we know for sure about the angles here? What do you notice about these angles? Well, I've got this diameter like we saw just a second ago. It's a chord, goes through the middle. So if that's a diameter, then what is this whole arc measure here? If I cut that circle in half, well, that whole arc's got to be 180. And if this is showing me that these two angles are congruent, I can split 180 in half and get 90 and 90. So now let's say x plus 93 equals 90. So what is x? X must be negative 3. Okay, I want you to try D. Keep thinking about what segments do you see here. How do they cut the circle? Keep that in mind here. Pause the video and try this next one. 2D. So here we notice again, that's 180. And what is this? If I've got 140 here, what's that missing part that is supplementary to 140? Well, that must be 40. So 6x minus 8 equals 40. And why is that? Well, I've got this arc being intercepted by a central angle. So they must be the same. 6x is 48, so x must be a positive 8. And let's move away from central angles for a second here to work with inscribed angles. So central angles were the same measure as the arc they intercepted. Then what happens to the angle as I move it twice as far back? So if I had a central angle of 98 degrees, what would this be? But what happens is I give that twice the distance. As I allow twice the space for this angle to open up here. What does that do to the arc? Well, it doubles it. So 98, I've got to double 98 to get that arc that it intercepts, since it's, an angle formed by that tangent line MT and the chord TR. It's kind of like an inscribed angle. So 180 plus 16 is 196 degrees for that arc, that major arc, TSR, and it's major because it's bigger than 180. So why don't you solve for B, C, and D here, pause the video, and check in after you've finished. So here I've got my arc is 210. That angle, what is that angle? 1. It's got to be half of that. Must be 105 degrees. And here the angle is 125. What's the arc? Well, that must be 250. Here's an interesting one, D. Let's draw the situation. Anytime you're unsure what to do, you can always draw a situation. Makes life a little bit easier for you. It's a great practice to get in the habit of to be a good mathematician. Now, an inscribed angle has its endpoints on a diameter. So let's draw a diameter. Let's draw an inscribed angle. Now, if this is a diameter, what is that arc measure? And what is this arc measure? What are these two arcs if I drew a diameter? Well, each one has to be 180. I cut that circle in half, right? It's a semicircle. Then what is this inscribed angle that intercepts 180 degrees? Well, it must be half, so it must be a 90-degree angle. And this is one we haven't looked at in quite some time. So let's revisit this. I've got an angle inside the circle formed by two chords. So what in the world do I do with these two? Well, if it's inside, is being inside a positive thing or a negative thing? Well, right about now, I'd say it's a pretty positive thing to stay indoors, which is incidentally what I'm doing right now. So we will take 130 and 156, and we can add those. Very positive thing to be inside. But then we've got to divide by 2. So what is it? 286 over 2. X must be 143. And if we wanted to find, this angle here, well, we could just look for what's going to form a linear pair. We could subtract from 180 and get 37. It's not the question right now, but it's an important thing to keep in mind. So why don't you guys try 5, pause the video, and see how it went. All right, 85 plus, we're inside the circle. Positive thing to be indoors. 145 over 2, that's 230. X is 115. All right, now what happens if I'm outside? Similar setup. There's one change though. What if I'm outside instead of inside? Well, being outside is a pretty negative thing. So we'll take the big arc minus the little arc. 178 minus 76, still over 2. It's 102 over 2. X is 55 degrees. So why don't you set up 7 same way? And you know what? When you set that up, why don't you multiply by 2 first? Get rid of that fraction. So there's a hint for you. Pause the video, set it up, try to solve for X. All right, now we're going to do the same setup here. So 114 minus X over 2 is 29. And like I said in that hint, let's get rid of that fraction first. How do I get rid of dividing by 2? It's the opposite of dividing by 2. Well, it would just be multiplying by 2. 114 minus X equals 58. So X must be 56. Yeah. Why don't you guys try 10, and we'll walk through 11 together, but try 10 on your own. I think that's a good exercise. Same setup. All right, so 3x minus 2 minus x minus 6 equals 34, but only after we divide by 2. And let's do the same thing here. I don't really like fractions. How do I get rid of dividing by 2? I can just multiply by 2 on both sides. 3x minus 2 minus x minus 6 equals 68. But now, let's be very careful about our positive and negative signs. If I distribute this negative, or if I find the opposite of both of these, 3x minus 2 minus x, minus a minus is like plus 6. It's 2 negatives. multiply together to become a positive 1 equals 68. So I've got 2x, do this in blue. I've got 2x, combine your like terms, plus 4 is 68, 2x is 64, x is 32. And this is where it's going to get kind of hairy. This is supposed to be plus, this is supposed to be plus. So let's go through 11 together, because, man, that's a difficult problem. But you know what? Why don't you start off with your setup first? I think once you set it up, you'll see that it's really not too bad. So x plus 70 minus x plus 30 over 2 equals x over 2. Now let's take a minute here, and after we've set this up, why don't you guys, if you haven't set this up already, try to solve for this one, because I really don't think it's going to be quite as scary as it originally appears once you've got that first step set up like we've just done. So if you're feeling brave, try that problem there, see if you can solve it. Otherwise, just hang on for another second and we'll solve it together. So let's get rid of our fraction. So opposite of dividing by 2 is multiplying by 2. Now, x plus 70 minus x minus 30, remember we've got to distribute that negative, equals x. And this is kind of a weird situation. We've got a positive and negative x. Those are going to reduce to 0. So now we're looking at 70 minus 30, 40. So these reduce to 0, equals x. And we're done. So again, that looks a lot scarier in its first, original format. But once you set up that first step, it's really not as scary as it first appears. And we've got some inscribed quadrilaterals, and then we'll find a couple radii, and I believe that's it. Yep, that's the last part that we've got for the day. So you've got to remember your inscribed angle theorem, that it's half of the arc it intercepts. But then, what do I know about these opposite angles? What do they add to? And it turns out they add to 180. So what is supplementary to 80? Well, that's got to be 100. Or 100 plus 80 gets me 180. 100. And now what's supplementary with 95? What adds with 95 to get me 180? And that is 85. So 100 degrees, 85 degrees. And we could always find these arcs that are intercepted, by 85. 85 times 2 would get me 170. It's not really what we're being asked here, but it's a preview of what we might see in a second. So why don't you guys solve for x and 13, and then we'll come back in 14 and 15 and work together a little bit more. So what do I know about the opposite angles here in an inscribed quadrilateral? Well, they've got to be supplementary. Plus 38x plus 5 is 180. And again, the reason why is these inscribed angles are half of the arcs they intercept. So here's angle G. And then if we look at, its opposite angle, A, well, what does that angle intercept? Well, that intercepts the rest of the circle. So a whole circle is 360. But these inscribed angles are just half of these arcs, or half of 360. So they must add to 180. So now I've got 59x equals 177, x equals 3. And I know a lot of you have pointed out that I really like the number 3. Just a coincidence. I keep trying to get away from the number 3, and then I forget whenever I make these worksheets. Oh well. Now let's look at number 14. The most important thing you can do is just take what your known values are and do whatever you can with those numbers. You know, just do whatever you can. Come up with whatever information you can just from those known pieces of information. What's the measure of this arc here that 110 intercepts? Well, 110 is inscribed, so that's got to be double, or 220. So we've got one thing, not super helpful. We still don't know how to solve for x yet. But what do I know about this angle that's opposite 110? What do these angles have to add to? Well, they've got to be supplementary. They've got to add to 180. So that must be 70. And now let's take a look at what angle is being intercepted by angle KRQ, or QRK. What's being intercepted by that 70? Well, we're pretty lucky here that they are exactly what we need them to be. This arc here is being intercepted by 70. So this arc is, the whole thing. I could take 50 plus 30x. But what does that measure have to be if my inscribed angle is 70? It must be 140. So now I've got 30x is 90, and who could have thought that x would be 3? I really genuinely did not expect that. But as you all know, I'm not a very original guy. So again, let's take our same stance as mathematicians. Let's take this stuff that we know. So we know this much, right? What's that whole big arc there? That's 214. Yeah. And what angle is intercepting 214? Well, let's follow these endpoints here. And that would be angle ADC. And it's inscribed, so it must be half of 214 or 107. So, just from that one piece of information, just taking these two known arc measures, we could find 107. And then what else could we find? Well, I know opposite angles have to be in some specific relationship. So what do those two add to? Well, those opposite angles must add to 180, must be supplementary. So this is 73. You know what? I should do that in a different color. Let's do it in pink. 73. And what can I do with that now? Well, here's this 73-degree angle. And would you look at that? Exactly the arc I want to find, ADC. And I'm given 73 for the inscribed angle. So arc ADC must be double that. Must be 146 degrees. So the most important piece of information I can give you here is just take what you're given. Take those given values and just find whatever angle or arc measures you can. And eventually you'll run into the exact question that's being asked of you. Now these are kind of difficult, so let's do one together. I know it's been a while since we've done one of these. So I've got congruent arcs here, congruent arcs, or not arcs, congruent chords. They do intercept congruent arcs. It's just a property of congruent chords. So congruent chords here, QR and ST, and QR we're given as 16. So 16, whole thing there. So QR is 16, which means that ST must also be 16. And if they're congruent, then what do I know about their distances from the center? Well, those have got to be the same too. So 2x must be the same as 5x minus 9. Or 3x must be, let's say negative 3x is negative 9. So x is 3. I honestly did not plan this. Yeah, the more you guys point it out, the more I do notice that you're right. 3 is a pretty common recurring theme. It is as Magic Schoolhouse. What? Schoolhouse Rock. It's 206. So just cut me a break here. Schoolhouse Rock. 3 is a magic number. I'm tired. So JK is 80. JK is 80. It's congruent to LM. Must also be 80. Or you know what? We didn't even find the radius. We found x. Let's find our radius. So x is 3. Then what's this? Well, that's got to be 6. And if this is 16, then what's QU? QR is 16. What's QU? Well, that's 8 and 8 because this segment goes through the center of the circle. So now I've got a triangle here. I can find this radius. Got a triangle here that looks roughly like this. Got 8 and 6 and a hypotenuse that I do not know. And if I use my Pythagorean theorem, a squared plus b squared equals c squared. 8 squared plus 6 squared equals what squared? That would be 10. 10 squared. So my radius is 10. So x is 3, but that radius is 10. All right, same thing here. Let's find our x first. But eventually we do want to solve for that radius. So this is just a reminder for me. Now if JK is 80, then what are these two parts here? Well, that's got to be 40 and 40. And what do I know about the distances from center? If I've got two congruent arcs, well, if they're congruent arcs, their distances from center must be the same. So 3x must be the same as 7x minus 12. 4x must be negative 4x is negative 12. X is, once again, 3. Who could have guessed? Who could have guessed 3? So this is 9. 9. Right here. 3 times 3 is 9. So we got 9 and 40. Let's do this in purple. So we got 9 and 40, and I want to find that hypotenuse using my Pythagorean theorem again. So 9 squared plus 40 squared equals what squared? And then if I solve for that, that would be 41. Incidentally, this comes from a cool theorem. Anytime you've got an odd number, you square it. So 9 squared is 81. And you can think about what are the two consecutive integers, the two consecutive whole numbers that add to 81, and that's 40 and 41. So a Pythagorean triple is 9, 40, 41. Just an interesting little side note on some number theory for you. So why don't you guys pause the video, try these last two, and then check back in, and we'll see how things went. All right, so I've got 5 and 5, so that's cool. Eventually I want to find the radius. But if they're equidistant from the center, then I know these must be congruent. So these must be equal expressions. So what do we have here? 2x equals 10, x is 5. And what's this thing? What's this whole segment here? So 5 times 6 is 30. Minus 6 is 24 for the whole thing, which if we break in half gets me 12 and 12. So now I'm working with, that's got to be 12. I'm working with the triangle that looks, more or less like this. I've got 12, 5, and a big old question mark. So 5 squared plus 12 squared equals x squared or y squared or c squared or whatever you want to call that hypotenuse. So I know the radius must be 13 after I use my Pythagorean theorem. And this one still works with that interesting theorem that I just told you about. 5 squared is 25. What two consecutive integers add to 25? Well, that would be 12 plus 13. 5, 12, 13. And our last one here, I said AC is 6. So if this is 6, well then that's 3 and that's 3. Now let's solve for x. X plus 5 equals 3x minus 1. 2x is 6. And of course, x is 3. So this is 8. This is 8. And I really do want my radius. Wow, that's not good. I'd like a radius, please. Thank you. So now what we're looking at is, do this in blue. I've got right angle. I want the radius. I've got 3 and 8. You could switch the 8 and 3. It really doesn't matter. So 3 squared plus 8 squared equals the radius squared. 9 plus 64 equals radius squared. 73 equals r squared. So that radius is root 73. And I don't believe that we could simplify that any farther. 73 is a prime number, so is 37. That's pretty cool. So we're just going to leave it as root 73 for right now. All right. Well, enjoy your last day of pre-spring break e-learning. And don't forget to do the mini quiz. And we will see you back here sometime eventually. Until then, stay safe. Spend some time with